Hi students, in this video we're going to take a bit more of an in-depth look at what makes a data point an outlier. So after this video you should be able to recall the rule for identifying outliers using the interquartile range. You should be able to use that rule to identify outliers and then finally draw box plots that include outliers and show what outliers look like in a box and whisker plot. Right, the things you have to recall: our box, creating a 5-number summary, calculating the interquartile range, and draw a box plot. Those 3 skills are foundational to working out scores that are outliers. Right, the definition of an outlier is any score that is either more than 1.5 or 1.5 times the IQR lower than the first quartile, or more than 1.5 times the IQR units higher than the third quartile. So basically how this looks is from our first quartile down, there'll come a point where anything below that point is an outlier. And similarly from our third quartile, there'll be a little range here. That range is 1.5 times the IQR. That's the same in both cases. Anything in that range, that's not an outlier, but anything beyond that range, like this point up here, that would be considered an outlier. So the key formula there is 1.5 times your interquartile range. Above your third quartile or below your first. Anything outside of those ranges is considered an outlier. Alright, so let's consider the following data set and work out if there's any outliers. Just looking at it, this score of 55 looks a bit dubious. It is much higher than all the others, but we need to see if it meets our definition and can actually be called an outlier. So we need to work out our 5-number summary first. So again, we'll do easy ones first. Our minimum is 5, our maximum is 55. Now looking at our data, we have 9 values. So to find our median, we'll go 9 plus 1, which is 10, divided by 2, which is 5. So our 5th score, 1, 2, 3, 4, 5. That 21 is our median. Now looking at our lower half, so we don't count the 21, but we don't count that median because it's actually because that median is an actual score in the data set. We need to find the median of these 4 numbers, so that'll be smack bang in between 11 and 13. So the average of 11 and 13 is just going to be 12. And halfway between 11 and 13 is 12, so that's our first quartile. Similarly, for our upper quartile, we've got 4 numbers. Our median will be smack bang in the middle of 26 and 30, 2 numbers either side. And then that average will be 26 plus 30 over 2, which will be 28, or halfway between 26 and 30, well, that is just 28. Right, and then to find outliers, or find out the limits of where our outliers can be, or what's considered not an outlier, we need to find our interquartile range. So that's our next step. So our interquartile range will be our difference between our first and third quartiles. 28, subtract 12, our interquartile range is 16. Now we need to work out where the edges of our data can go before we consider it an outlier. So using our formulas, we've got our first quartile and then 1.5 times our IQR lower. That's why we're subtracting. We're going smaller than our first quartile. So our first quartile was 12, and we'll subtract 16 by 1.5. 16 by 1.5 is 24. 12 subtract 24 is negative 12. We don't have any values on the low end even close to negative 12, so none of those values are outliers. Now let's look on the upper end and see if that 55 is actually an outlier. Our third quartile is 28, and this time we're going higher, so we're going to add 1.5 times 16. So 1.5 times 16 is 24. 24 plus 28 is 52. So anything beyond 52 can be considered an outlier. our last value is 55. So therefore, because 55 is on the outside of our limits, 55 is an outlier. All right, now let's use that fact to help us create a box plot. So we're going to just include our 5-number summary again. Okay, so we've got all our values there, and we just need to plot them. So our minimum was 5. Our first quartile was 12, which is about there. Our median was 21, which is about there. Our third quartile is 28, which is about there. Now, at this point, our maximum, our score of 55, we just saw on the last page that that was an outlier. So what we're going to do is up at 55, I'm going to put a cross, right? You could put a circle, you can put just a single dot on its own. I like to use crosses because it just means it's less confusing when doing my sketch. So I'll put a cross at 55, and the box plot will now end at 30. So that 55 is a cross, 30 is within my range, that one's not an outlier, so my box plot should finish there. And drawing that neatly, there's our box plot. We've got our values, we've got our box plot here on the left that has all of our numbers within our range that aren't outliers, and our outlier at the end here marked with a cross. Right, so after watching this video, you should be able to recall the rule for identifying outliers using interquartile range. So that's starting with the first quartile, anything lower than 1.5 times the IQR below our first quartile, or anything higher than 1.5 times the interquartile range above our third quartile. Those are the rules that you'll need to know. You'll need to be able to use them to identify outliers in a data set. That was what we did in our example. And then draw a box plot that includes outliers. That's what we did in our second example.